Hey Honors Math, today is Wednesday, May 6th. The good news is we're starting a brand new section today, a brand new chapter. So we are now starting chapter 8, which is going to focus on polynomials. And the first section we're going to talk about what are polynomials, and we're going to talk about adding and subtracting polynomials. So what I would like you to do first today, real quick, is I would like you to read in your book pages 465 to 467 before you actually do the video and take notes. I just think it's helpful because that way you kind of have an idea of what I'm about to start talking about. As you're watching the video today, you're going to make sure you take notes because you will be submitting your notes as your assignment today. Okay? All right, so take a pause, read those pages, and then come back and watch the video. All right, so the first thing we're going to talk about is what is a polynomial, because if I'm going to start talking about these, then you got to know what they actually are. So polynomial just means how many terms does a algebra expression have, okay? So a polynomial can have one term, two terms, three terms, or multiple terms, and they each have different names. Now, when I say terms, I don't mean number of variables, okay? Terms, okay, are separated by addition and subtraction. Okay, I hate that word, so I hope I spelled it right. Separated is not one of my forte spelling words. So terms are separated by add or subtract. Okay, so we have mainly been working with monomials up to this point. Okay, what does the prefix mono mean? Means they only have one term. So we really haven't had any addition or subtraction terms in the last chapter. So an example of a monomial is something like x, or xy, or x squared, y squared, or a, b, c, or x, y, z squared, or just a number like 5. Those are all monomials, and the reason why is because they have no addition or subtractions. They have one term. So one term, one term, one term, one term, one term, one term. Okay? Now, you may be saying, well, I don't understand. ABC has 3 variables. Why isn't it a trinomial? We're not talking number of variables. We're talking number of terms. So you're counting up how many terms are separated by addition or subtraction. Okay, so binomial, the prefix, is bi, which means binomials have 2 terms. Okay, so something like x plus y, 2 terms. What do I mean? There's one term and one term separated by an addition sign, so that's 2 terms, binomial. All right, we could do something like z plus 6, because the z is a term, the 6 is a term. There's one addition sign that's separating the 2. Okay? We could do something like x squared plus y squared. Again, 2 terms, one addition sign. We could even do something like xy plus ab. Okay? Even though there's 4 variables, there's only 2 terms. Now, here's a tricky one. So what if I gave you this? 2x plus y plus 4x. Now, no, Ms. Leslie's not going crazy. It's not 3 terms, because what you have to do first is you have to see, can you combine any terms? So if I take 2x and I take 4x and I combine those, that's actually 6x. So this is actually 6x plus y. So again, if you look, there are 2 terms. Makes it a binomial. Okay, so I wrote too big, so I'm going to go to the next page and talk about trinomials and polynomials. All right, so the next kind of polynomial we're going to talk about is trinomial. So again, the prefix tells you how many terms. So trinomial means there's going to be 3 terms. And I'll be honest with you, in algebra, we probably deal with trinomials more than we do anything. Okay, so an example of a trinomial is something like x squared plus 3x plus 5. Why? Because here's 1 term, here's 2 terms, here's 3 terms. Again, terms are separated by addition, subtraction. Okay? Another trinomial would be something like y to the 4th, z to the 3rd minus 9yz plus z. Okay, so again, there's one addition, one subtraction sign, so that means there has to be 3 terms. So here's term 1, here's term 2, here's term 3. Okay, so I hope you get the idea of what a trinomial is. Now, the other thing I'm going to mention just real quick, these 2 trinomials that I just wrote are written in what is called, I shouldn't say they both are because that's not true. Well, yeah, actually they are. Sorry, I had to agree with myself. They're called, they're written in descending order, okay? So let me write that down, descending order. So you need to know what that means. And you're going to hear that a lot probably next year in honors algebra or algebra, whichever one you take. Descending order means if you look at the variable in the problem, so if I look at that first trinomial, x squared plus 3x plus 5, the x's are what are called descending order, which means if you look, the power on this x is 2, the power on this x is an imaginary 1, and then there is no power of x here. So if you look, 2, 1, 0 goes in descending order. It goes down. That's called descending order. Now, if you look at the second one, I have to tell you which variable to focus on. So if I look at just the y, okay, so the y here is 4, the y here is an imaginary 1, and then there is 0y here. Again, that's descending order, 4, 1, 0. We don't have to have a 3 and a 2. It just has to be in descending order. Now, the opposite of this would be ascending order. So ascending order would mean whatever variable I tell you, they would be going up instead of down. So descending order is down, ascending order is up. Okay, so if I look at that first trinomial back in blue, x squared plus 3x plus 5, if I wanted to make that in ascending order according to x, then I would write it as 5 plus 3x plus x squared. Because, again, in this first term, there are no x's. In this second term, the power on the x is a 1. And on this last term, the power of the x is 2. So 0, 1, 2, ascending. Now, in the second trinomial, again, if I said according to y, we would again just totally write it backwards. Z minus 9yz plus y to the 4th, z to the 3rd. And again, if you look at just the just the y's, I got to get my variables straight. There's 0 y's here. The power on this y is 1, and the power on this y is 4. So 0, 1, 4 goes up, ascending order. Okay? So this last one we got to talk about is polynomials. So the prefix is poly. So poly means many. So polynomials means many terms. Well, it's kind of generic. What we do with the word polynomials, what we do is anything that is more than 3 terms, we don't name them. There's no such thing as a quadrinomial or a, I don't know, what would it be called, a pentanomial? Anything with more than 3 terms, we just call a polynomial. So if I wrote something down like x squared plus 5y minus 6x plus 10, how many terms is it? Well, there's 1 term, there's 2 terms, there's 3 terms, there's 4 terms. So instead of calling it anything else, we just say it's a polynomial. Okay? So that just introduces this whole idea of this word polynomial. Okay? So here we go. Okay, so the next thing that we're going to talk about is there's a lot of vocabulary in this section at the beginning. And of course, we got to talk about that before we can actually do anything with these polynomials. So the next thing we need to talk about is I need to be able to ask you what's the degree of a polynomial. Okay, now when we talk about degree, we're not talking about temperature. The degree of a polynomial just kind of signifies what kind of polynomial it is. Not talking monomial, binomial, trinomial, but we're talking about the degree. Okay, so we can't talk about the degree of a polynomial until we talk about how to find the degree of a monomial. We always have to start everything with a monomial. Okay, so these all below are monomials. Okay, why? Because they don't have any addition subtractions. signs. So the way you find the degree of a monomial is you're going to focus just on the variables and just on the exponents. So if I look at this first monomial, x squared y cubed, okay, the exponents are 2 and 3. So the degree of that polynomial is you add up, and when I said polynomial, I meant monomial. When you just add up the exponents. So 2 plus 3, the degree of that monomial is 5. What do you do with that? Nothing. You just have to be able to find the degree of it, okay? If you look at the second polynomial I listed, ABC, looks like there's no exponents, but technically there are. There's an imaginary 1 here, 1 here, 1 here. So the degree of this monomial is, again, we add up the exponents, 1 plus 1 plus 1. The degree of that monomial is 3. Okay, look at the next one, 9. It's a monomial, but it's just a number. But in algebra, it's not just a number. We call it a constant. Okay, so a constant, what's the degree of it? Well, you notice there's no variables, there's no exponents. So the degree of that 9 is actually just 0. So if you have a constant, it doesn't have a degree, it's just 0. All right, moving on to the third monomial, 4x squared y cubed z. You have to be very careful here. A lot of people would say, oh, it's 2 plus 3 is 5. But there's that imaginary 1 on the z you can't forget. So we have 2 plus 3 plus 1. So the degree of that monomial is 6. Okay, what about 7x? Well, again, the 7 doesn't really mean anything, but the x has an imaginary 1 on it. So the degree of that monomial is 1. Okay, 9x squared y squared z cubed. Again, focus on the exponents. Again, the 9 doesn't have anything to do with the degree. So 2, 2, 3. So if I take 2 plus 3, that's 7. The degree of that monomial is 7. All right, so now we can find the degree of a polynomial, okay? Now, if I asked you right now, if I said name these polynomials, I would hope you would say that the first polynomial, x squared plus 5x plus 6, has 3 terms, so it's a trinomial. The second polynomial, 3x squared y plus 9x cubed plus 7x, 3 terms, is a trinomial. And then this last big polynomial, 6xyz minus 3 plus 2x squared y squared z squared minus 9x to the 8th, that's just a polynomial because it has 4 terms. But we're talking about degree. Okay, so you can't do the degree of a polynomial if you don't know how to do the degree of a monomial. So think about, what is a trinomial made up of? A trinomial is technically made up of 3 monomials. So what we're going to do is we're going to find the degree of each of those monomials that make up that trinomial. So if you look at x squared, the degree is 2. 5x, there's an imaginary 1 here, so the degree of that monomial is 1. And the degree of 6 doesn't have any exponents, so it's 0. But it doesn't mean we add up these degrees. The degree of the polynomial is whichever number there is the highest. So the degree of this polynomial is 2 because 2 was the highest degree. All right, look at the second polynomial. Okay, so again, here's term 1, term 2, term 3, so we have to find the degree of each one. 3x squared y, there's an imaginary 1 here, so 2 plus 1 means the degree of that monomial is 3. 9x cubed just has 1 exponent, the degree of is 3. And then in that last monomial, 7x, there's a 1 there, so the degree of that monomial is 1. Now, it's okay if we have a tie. So the degree of this polynomial is, which number is the highest? Well, we have 2 of them. They tie at 3, so the degree of that polynomial is 3. Okay, let's look at this last polynomial. So we have 1, we have 2, we have 3, we have 4 terms. So we have to find the degree of each term. So 6xyz, there's an imaginary 1 on every one of those variables. So 1 plus 1 plus 1 is 3. This next term, negative 3, is just a constant. And we said a constant didn't have a degree, so that's 0. 2x squared y squared z squared, if you add up the exponents, not the 2 in the front, not the coefficient, that's called a coefficient, but just the exponents, 2 plus 2 plus 2 is 6. And then the degree of the last term is just the 8. Okay, so the degree of the polynomial, again, you don't add them up, you just take the highest. Which number is higher, 3, 0, 6, or 8? The answer is 8. Whoops, I can't write the 8. 8. So the degree of that polynomial is 8. Okay, the last thing that your book talks about before we actually start adding and subtracting polynomials, which is kind of the meat of this section, is we're going to talk about two more vocabulary things. One is called standard form and the other is called leading coefficient. Okay, so I've already kind of alluded to standard form, but I alluded to it as saying descending form. So standard form means if I say write the answer in standard form, I want you to write the polynomial so that your variables are in descending order. So standard form is a fancy way of saying descending form. Now, in honors algebra, they might use either of those. Okay? So if I look at this polynomial that I have here, 3x minus 9 plus 4x squared minus 6x, and I said, I want you to write that in standard form. Okay? Well, the first thing you have to notice is I have two terms that can be combined. Okay? 3x and negative 6x, I can combine those into negative 3x. So I'm going to rewrite this polynomial as this, just to begin with. Okay, so now I want it in descending order. So again, I'm going to look only at the variables. So if I notice, I have a variable with an exponent of 2. This x has a variable of 1, and then the negative 9 doesn't have any x's. So descending order means go highest to lowest. So I am going to write 4x squared first, and then the next term with the next lowest exponent would be negative 3x. So I'm going to write negative 3x. And then lastly, I'm going to put the negative 9 on the end because it doesn't have a variable of x, so it doesn't have any exponents. That right there is in descending order or standard form. So this other fancy word up here, leading coefficient, means once you have put your polynomial in standard form, the leading coefficient is just whatever number is way out front. So this 4 right here is called your leading coefficient. But again, you can't identify the leading coefficient until your polynomial is actually in standard form. Okay? All right, so now we're going to get to the real meat of this section. So far, all we've done is really talk about vocabulary. Okay, so here we go. Now, I would almost say that today is the start of a whole new math world for you. So what we're going to talk about today is we're going to talk about sums and differences of polynomials. Now, I would hope when you see the word sum, you know that that's addition, and different means subtraction. So today we're going to focus on adding and subtracting polynomials. Well, what you're going to find out, and unfortunately we won't get very far with this, is this entire chapter focuses on adding and subtracting polynomials, multiplying polynomials, and dividing polynomials. So all of our basic operations, add, subtract, multiply, and divide, can be applied to polynomials, okay? Unfortunately, we're not going to get very far. I'm hoping that maybe we'll get to multiplying, okay? So here we go. Let's start with adding and subtracting. Okay, so here's our first problem. So we're being asked to take 2x squared plus 5x minus 7 plus 3 minus 4x squared plus 6x. Well, the first thing that you have to know is you can only add and subtract like terms. Now, when I say like terms, what I mean is x squareds and x squareds are alike. X's and x's are alike. Constants are alike. If I had a term that had an x and a y, it could only go with an x and a y term, okay? So if I look at this problem, okay, I am going to start with, really it doesn't matter where you start, I am going to start with the first term in the first parentheses, 2x squared. And then I'm going to look over to the right-hand parentheses and ask myself, is there a term that's like it? The answer is yes. So I'm going to underline not just 4x squared, but negative 4x squared. What does the problem say that I'm going to do with these two terms? I'm going to add them. So I'm going to write it out, and eventually you're going to be able to do this in your head, but for now, let's write it out because I promise you we can make some silly mistakes if we don't. So if I said, what's 2x squared plus negative 4x squared? Okay, I get all kinds of answers here. I get people saying 2 plus negative 4 is negative 2. X squared plus x squared is x to the fourth. No. Okay? And it's not 2 plus negative 4 is negative 2 and x squared cancel out. No. This is like saying, what is 5 apples plus 4 apples? 9 apples. I just take the numbers in front and I add them together. So if I take 2 and I add negative 4, 2 plus negative 4 is negative 2, and then I just put the x squared on my answer. So 2x squared plus negative 4x squared is negative 2x squared. Okay, so the next thing I do is I look at the second term in the parentheses. So it's positive 5x. Now I want you to notice I'm underlining things because I don't want to leave anything out. It's so easy to leave stuff out if you don't do this underlining that I'm doing, okay? So if I have positive 5x and I have positive 6x over here, and again it says to add them, so I'm going to write down 5x and I'm going to add positive 6x. What's that give me? Well, again, the x stays the same. 5 plus 6 is 11, so plus 11x. Okay, got one more term in each parentheses. So if I focus on my negative 7 and my positive 3, and again it says plus in between, so if I take negative 7 plus 3, that's negative 4. Okay, so my answer to this problem is negative 2x squared plus 11x minus 4. Now, before you guys get to any assignments or anything, I know I'm going to have students go, okay, what order do we write our answer in? I want you to always write it in standard form. Remember, that means the variables go, the exponents go down. But if you have more than one variable, you don't have to worry about it. It doesn't matter what order you write it in. Okay, so is my answer in descending order? I don't know. Let's see. So 2, imaginary 1, and a 0. So yep, that's my answer. But again, you know, because you're so new at this, if you gave me the answer 11x minus 2x squared minus 4, I'd be happy with that because it's the same answer. It's just not in the correct standard form. But right now, I'd just be happy if you have the right answer. Okay? The only reason right now standard form is important is because it makes it easier to grade. Now, you will find out later on it's very important that you put it in standard form. Okay? All right, let's go on to number 2. Okay, here's problem number 2. And I should have mentioned on the last problem, when you're doing the problem, don't try to do it in standard form. Just do the problem as is, and then you can always rearrange the order in your answer. Okay, so where do I start? Well, honestly, it doesn't really matter where you start as long as you underline or circle or something things. Because if you don't, I guarantee you, you're going to leave out terms. Now, what I would not do is I would not mark things out. I see students do that all the time, and then they have a mistake, and we can't tell what their mistake is because they've marked out their terms. Okay, so kind of follow along how I do this. All right, so first of all, and colored pencils or colored markers come in very handy too here. So if I look at the first parentheses, I'm going to look at that very first term, and I'm going to underline it, 3y. And then I'm going to look over at my second parentheses and say to myself, is there anything alike over there? The answer is yes, there's a negative 4y. And you need to notice that it's plus in the middle. So I'm going to write down 3y plus negative 4y. And I would hope we all know the answer is negative 1y. Okay? All right, so let's move on to the next term. So in the second parentheses, I see y cubed. In the second parentheses, I see a positive 2y cubed. And again, it's addition in the middle. So if I take, that's a 1y cubed, and I add 2y cubed, 1 plus 2 is 3, so I have plus 3y cubed. Okay? Again, let's look at the first parentheses. I've got this negative 5. Do I have a constant in the second term? Yes, I do. Or the second parentheses? Yes, I have a positive 8. So I'm going to write down negative 5 plus positive 8. That gives me positive 3. Now, let me stress right now, do you see why I underline and circle stuff? Because I don't have the same amount of terms in the second parentheses as I do the first. I can promise you that if you don't do the underlining, the squiggly, and the circle things, many of you would leave out that lonely little 4y squared in the second one. So what do I do with this 4y squared that's sitting here? Well, there's nothing in the first parentheses to put with it, so it's just plus 4y squared. Okay, so plus 4y squared. So right now my answer is negative 1y plus 3y cubed plus 3 plus 4y squared. Okay, so yeah, that's fine, but again, correct standard form would be put the variables in order. So which one comes first? The highest is 3y cubed. The second highest is plus 4y squared. Make sure you actually take the operations down. Got to have operations between each term. Then the next term is negative 1y. And then I have my constant at the end. Now, that answer right there is perfect, but you could also write it as 3y cubed plus 4y squared minus y, don't have to write the 1, plus 3. There's my final answer in standard form. Now, what if I said, what's the leading coefficient? Hopefully you just said to yourself 3, because it's the number in front. Okay? Okay, so now we're going to move on to subtraction. Okay, so I am here to say that I could tell you this a million times, and many of you are going to make mistakes in subtraction. The reason why is because of this right here. Many of you will forget to pick up the minus in between the parentheses. Trust me, it's going to happen. If I could open your brain and pour this in, it'd be great. So listen extra carefully to what I'm about to say. Okay? All right, so again, we're going to do just like addition. We're going to find like terms. So if I look at my 6y squared, is there anything like it in the second parentheses? Yes, there's 2y squared. Now, this is where I have people make mistakes all the time. They want to write down 6y squared, and then it's a positive 2y squared, and oh, it's 8y squared. No. Here's the problem. You didn't pick up the subtraction. So it's not add, it's subtraction. You got to pick up the minus sign. So 6y squared minus 2y squared is 4y squared. Okay? All right, let's go to the second term. So I have an 8y to the fourth, and I have a 9y to the fourth. But again, pick up the subtraction. It almost helps to say it. So 8y to the fourth, pick up my minus sign, 9y to the fourth. 8y to the fourth minus 9y to the fourth gives me negative 1y to the fourth. Okay, so now I've got a negative 5y, and I have a negative 7y. Real easy to make a mistake here because there is a minus. I see people do this all the time. They write down negative 5y, negative 7y, it's negative 12y. But what did we do? We forgot to pick up the minus in the middle. So it should say this, negative 5y minus negative 7y, which is plus 2y. Okay, did I get all my terms? Yes, I've underlined, I've circled everything. So is this in descending order or standard form? No. Y to the fourth has to come first. Then my y squared, and then my 2y. Now, again, I don't need to write the 1, so technically the best answer here is negative y to the fourth plus 4y squared plus 2y. There's my answer. Okay, here's another problem, subtraction. So if you would like, go ahead and pause the video and try this, and then come back and we'll go over it together. All right, so here's how I started the problem. So I started with the first term in the first parentheses, and I found its matching term over in the right parentheses. So I have negative 8xy. I got to pick up the minus in the middle, so negative 8xy, the minus in the middle, and then the positive 6xy in the parentheses in the second one. So negative 8xy minus positive 6xy, that's negative 2xy. Okay, if I go to the second term in the first parentheses, I have positive 3x squared. I pick up my minus, and then positive 4x squared. So I have 3x squared minus 4x squared. So that gives me negative x squared, or negative 1x squared, either way you want to do it. Okay, third term in the first parentheses, negative 5y, pick up the minus, and then I have a negative 2y over here. So that gives me negative 5y, pick up the minus, negative 2y. I add the opposite, that gives me negative 3y. Okay, so now some people would go, oh, I'm done because I've picked up everything in the first parentheses. But what you got to be careful with is right here, we actually have a negative 3x still standing, and we didn't have an x term in the first parentheses. Now, it's not just minus 3x here because we didn't pick up the minus. You still got to pick up the minus. So it's minus a negative 3x. So right now, this is my answer. Okay, but I'll be honest, I don't like the way it looks. Now, because this has two variables in it, you don't have to worry about any kind of standard form. Because when you have two variables, the only way you can put it in standard form is if I tell you what variable to put it in order for. So you don't need to worry about order on this problem. You just need to finish it up. So negative 2xy minus x squared minus 3y, and then minus a negative makes a plus. So there's my final answer right there in yellow. Okay, last one for our notes today. So this one doesn't have two parentheses that we're adding or subtracting. It has three. So you just got to be careful because if you notice, it's the minus in the first one and then there's a plus. Now, some people would say, well, I'll take the first parentheses, 4x plus 2y minus 6z, and then I'll minus the second parentheses, negative 5y minus 2z plus 7x, get that answer, and then add the last parentheses. You can do that if you want. Me, I just do the whole problem at once. So here's what I do. And again, the underlining and circling helps a lot. So I'm going to underline my 4x in the first parentheses. There's a like term in the second parentheses, a positive 7x. And there's a like term in the last parentheses, negative 9x. Now, I just realized something, so I'm going to change the problem just a tiny bit. So if you stopped this problem, you're going to be like, wait a minute, she changed the problem, and she did. So we're going to make this a minus 2y. Sorry, they can't be, I don't want them to have like terms in that last parentheses. Okay, so I've underlined all the x terms. So I'm going to write down the problem. So I have 4x. I need to pick up the minus. And then I need to pick up the positive 7x. And then I need to pick up the plus. And then I need to pick up that negative 9x. So there's what I have. So 4x minus positive 7x gives me negative 3x. Negative 3x plus negative 9x gives me negative 12x. Okay? So I'm ready for my second term. So I have a positive 2y. So I'm going to write that down. I'm going to pick up my minus. I have a negative 5y in the second parentheses. And then I'm going to pick up my plus. And there is a negative 2y down here. Okay? So again, if you actually turned off the video and did the problem by yourself, I actually changed that last parentheses. I didn't want to have like terms. So if you didn't change it, you're going to have a different answer here. Okay, so 2y minus negative 5y gives me positive 7y, and then 7y plus negative 2y gives me positive 5y. Okay, all right, so now what do we have? We have a negative 6z. Pick up my minus. I have a negative 2z here. And then I don't have anything in the last parenthesis, so I can't pick anything up. So negative 6z minus negative 2z gives me negative 4z. Now, before I go any farther, I ask myself, did I pick up all the terms? So in the first parentheses, there's nothing left. Second parentheses, nothing left. Third parentheses, nothing left. And again, because I have more than one variable, I don't need to worry about actually putting this in any particular order. So I'm just going to leave it as is. Negative 12x plus 5y minus 4z. Okay? All right, so what you need to do today is submit your notes. This was your assignment for today, and then tomorrow you'll actually have an assignment to practice these skills in your book. All right, have a great day.